Hi, I'm Herb Gross, and welcome once again to Gateways to Mathematics, where today we'll be doing the solutions for Self-Test 6, Form B. And as usual, make sure you've tried all these problems before you go through the solution with me. And once again, let me remind you, it is perfectly permissible to work on Form B before you work on Form A. In fact, you may want to use the two forms interchangeably. Whatever style, as I say, suits you best, please feel free to use it. And since there's quite a few problems to go through, let's go to the board and start right in with them. What we're going to be doing in this particular self-test is a lot of review, basically in terms of our second language concept that we talked about in the lecture. Most of the new work is simply going to be to translate from mixed numbers into common fractions, then from common fractions back into mixed numbers. And with the exception of that, everything else is basically a review, except possibly for the concept of percents, which we just introduced in this module. Now, in the first four problems, just because I want to illustrate a particular point, and I don't want you to be bogged down with computation, I pick the same three numbers over and over again through all the parts of the first four problems. And in particular, the three numbers I use are 10 1/3, 3 1/2, and 1 3/5. And remember how we convert a mixed number to a common fraction? The denominator times the whole number plus the numerator over the denominator. Remember how we're viewing that. If there are 3 books to a carton and you have 10 cartons, in 10 cartons you have 30 books plus one of the 3 books that you need to form the 11th carton. 3 times 10 is 30, plus 1 is 31 over 3. So the common fraction name for 10 1/3 is 31/30. 2 times 3 is 6, plus 1 is 7. 7 over 2 is 7/2, so 3 1/2 becomes 7/2 when we write it as a common fraction. 1 3/5, 5 times 1 is 5, plus 3 is 8 over 5, so 1 3/5 becomes 8/5. Okay? So that's the 3 fractions I'll be using, the 3 mixed numbers that I'll be using throughout the first 4 problems. And so I'll go through that part fairly quickly just to make sure that you see the highlights. All right? And in exercises 1 through 6, our command is to write all the answers as mixed numbers. That's why you don't see problems, just things on the board. In other words, any problem that you see here, the command is to write the answer as a mixed number. Problems 7 through 10 will deal more with verbal situations, how to use this material to solve problems. Okay? Let's just get started and see what happens. Problem number 1 says 10 1/3 plus 3 1/2 plus 1 3/5. We want to find out what that answer is. And by the way, don't be afraid to estimate answers here. 10 1/3 rounded off to the nearest whole number is 10. 3 1/2 is around, let's just call it 3. 10 and 3 is 13. And 1 3/5 rounds off to 2. That's 15. So we expect an answer around 15. Okay? Now let's just see what happens. What's the technique? We translate from our second language, mixed numbers, into the language of common fractions. And using the result I showed you before, the 10 1/3 becomes 31/3, the 3 1/2 becomes 7/2, and the 1 3/5 becomes 8/5. From this point on, we proceed exactly as we did in modules 4 and 5, because we're back to common fractions. With denominators of 3, 2, and 5, 30 is the least common denominator. 3 goes into 30 10 times. 10 times 31 is 310. 2 goes into 30 15 times. 15 times 7 is 105. 5 goes into 36 times. 6 times 8 is 48. Now what we've done is we've rewritten all of the common fractions in terms of a least common denominator, at which point all we have to do now is what? Add the numerators and keep the common denominator. And if that part gives you trouble, remember that's a problem that deals with modules 4 and or 5, not with module 6. See, so we add these numbers up. The numerators add up to 463. 463 what? 463 30ths. So we now have the answer as a common fraction, but the command is to leave the answer as a mixed number. So we simply swing the 363 down. We divide the 30 into 463. 30 goes into 46 once. 30 from 46 is 16. We bring down the 3. 30 goes into 163 5 times. 5 times 30 is 150. 150 from 163 is 13. So the answer is what? 15 with a remainder of 13. And we write the remainder over the divisor. So for a mixed number, the answer is 15 and 13/30. 15 and 13/30. And again, because this was purely an addition problem, it turns out that there was a faster way of doing this. You see, what we could have done is recalling that 10 and 1/3 means 10 plus a third, and that 3 1/2 means 3 plus a half, and that 1 3/5 means 1 plus 3/5. Since this is a pure addition problem, we can use the associative and commutative properties and regroup the numbers so that we add the whole numbers and add the fractional parts. And to do that, the common way of doing this is we again pick our common denominator. With 3, 2, and 5, the common denominator is 30. So 10 and 1/3 is written as 10 and 10/30. 3 1/2 is written as 3 and 15/30. 1 3/5 is written as 1 and 18/30. 10 plus 3 plus 1 is 14. 10 plus 15 is 25, plus 18 is 43. 43 what? 43/30. But we can't leave the answer like this, because for a mixed number, remember, there must be a whole number plus a fraction which is less than 1. In other words, a fraction in which the numerator is less than the denominator. Notice that every 30/30 gives me 1. So basically, I divide 30 into 43. I get 1 with a remainder of 13. So the 14 and the 1 gives me 15. 15 plus 13/30 is 15 and 13/30, which is the same answer I got the other way. Which is the correct way to do the problem? Whichever way you feel more comfortable. Okay? Now we're going to do the same problem, well, the same numbers, but now we're going to be multiplying. See, we're going to take 10 1/3 times 3 1/5 times 1 3/5. And the style is what? Rewrite 10 and 1/3 as 31/3. Rewrite 3 1/2 as 7/2. Rewrite 1 3/5 as 8/5. Now it's a common fraction problem. How do you solve a common fraction problem when you're multiplying? You multiply the numerators and you multiply the denominators. And let me just give you one word of advice here, or not advice, maybe just caution or whatever you want to call it. We've been talking about reducing fractions to lowest terms. In other words, we could say 2 goes into 8 4 times. All I want to point out is that in a little while, namely in a few more lessons, we'll start using the calculator. When you use the calculator, it's much quicker to just multiply numerators and then divide by the product of the denominators and not fool around reducing to lowest terms. So in a problem like this, you could say what? 31 times 7 times 8. And even though I leave the details to you, on the corner here, I've just written out the multiplication so you can see how I get at this. So the numerator is 1736. The denominator is still 30. So as a common fraction, the answer to this problem is 1736 over 30. And now the final step is what? I've got the answer as a common fraction. I want the answer as a mixed number. So I simply come over here, all right? I divide 30 into 1736. 30 goes into 173 5 times. 150 from 173 is 23. I bring down the 6. 30 goes into 236 7 times. 7 times 30 is 210. I subtract, the remainder is 26. 26 what? 26/30, but in lowest terms, 26/30 is the same as 13/15. So the answer to this problem is 57 and 13/15. And again, let me apologize for something. In the first edition of the study guide, the answer is incorrectly given as 57 and 13/30, as opposed to 15 and 13/15. And by the way, let me come back to the beginning of this problem for just 1 second or two to point out again what I don't want you to do. You see, this is the correct answer to the problem. A very common mistake that people still tend to make is they want to multiply the 10 by the 3 by the 1, then the 1/3 by the 1/2 by the 3/5. Be careful, since this is a distributive type of problem. You see, these are plus signs assumed to be in between here and here. So you're dealing with addition and multiplication in the same problem. If you insist on doing the problem this way, remember each part of each number has to multiply each part of every other number, and that can become quite a tedious task. Okay? Well, anyway, let's go on and go through the basic operations. So far, we've done addition and multiplication. We still have subtraction and division ahead of us. And the nasty part about subtraction and division is that they don't have the nice properties that addition and multiplication have. So usually when I give you a subtraction problem or a division problem, it will always come in two parts, mainly because the grouping is important. So problem number 3a asks us to take 10 1/3, subtract 3 1/2, and then subtract 1 3/5. Notice that part B looks like exactly the same problem, except that now we're first going to subtract the 1 3/5 from the 3 1/2, and then subtract that result from the 10 1/3. Do you see the idea here? If we left the grouping symbols off, both problems would look exactly alike. Okay, let's see how we do part A. Again, all we're going to do is we're going to replace 10 1/3 by 31 thirds, 3 1/2 by 7 halves, and 1 3/5 by 8 fifths. As soon as we've done that, until we come to the very last step in this problem, the rest is going to be a Module 4 or Module 5 problem. You see, once I've done this, I've got a common fraction problem. And we dealt with these kind of problems in exercise set 4. See, so what am I going to do here? I'm going to find the common denominator. With 5, 2, and 3, the common denominator is 30. This becomes what? 331 over 3 is the same as 310 over 30. 2 goes into 30 15 times. 7 times 15 is 105. 5 goes into 36 times. 6 times 8 is 48. See, even though I do all the arithmetic in the parentheses first, I can find common denominators at the same time. See, what some people do is they will do this problem finding only a common denominator for the 2 and the 3, get this part done, then work with the 6 and the 5. You can do it that way. All I'm trying to show you is that if you get the common denominator all at once, when you do part B, you're going to be able to use exactly these same numbers, but just switch the parentheses. At any rate, you see 310 minus 105 is 205 thirtieths. We subtract 48 thirtieths from 205 thirtieths. That leaves me with 157 thirtieths. That's the answer as a improper fraction. I now divide the 30 into 157. 30 goes into 157 5 times. 150 from 157 is 7. So the answer is what? 5 and 7 thirtieths. And again, since this is a subtraction problem, you could have done this the same way as we did the addition problem, but you have to be careful. In other words, what you could have said is, look, 10 1/3, and I want to take away 3 1/2. A common denomination for 3 and 2 is 6. So 10 1/3 is the same as 10 2 6. 3 1/2 is the same as 3 and 3 6. Now you go to subtract. You can't take 3 6 from 2 6. So you go over here and you borrow. But the thing I want you to notice here is that you're dealing with 6. When you borrow one, you exchange it not for 10 6, but for 6 6. In other words, your new fraction over here becomes 8 6. So you don't put a 1 over here because that would be 10. You're only exchanging for 6s. 8 from 3 is 5, so the fraction part is 5 6. 3 from 9 is 6, so the answer so far is 6 and 5 6. Then I want to subtract 1 3/5 from that. A common denominator for 6 and 5 is 30. 5 6 is the same as 25 thirtieths. 3/5 is the same as 18 thirtieths. I go through that part rapidly because that should be a review based on the fact that you've already done modules 4 and 5. 18 thirtieths, take from 25 thirtieths to 7 thirtieths. 1 from 6 is 5, and I have the same answer as before, 5 and 7 thirtieths. Which is the best way to do it? Again, whichever way you feel comfortable. But don't pick a way that you get comfortable with that you're using incorrectly. If you find a comfortable way, make sure it's the right way. Okay, part B is the same problem, only with a different grouping. See, so just to recopy what I've done, you see the denominators are 3, 2, and 5. So the common denominator is 30. I rewrite each of these using 30 as the common denominator. That should give me the same 3 numbers I had in part A, only with a different grouping. You see here I first subtract the 48 from the 105 because everything inside the parentheses is done first. You see 48 from 105 is 57. 57 what? 57 thirtieths. I now take the 57 thirtieths and subtract that from 310 thirtieths. 57 from 310 is 253. So I now have 253 thirtieths. The problem with that is that that's the right answer as a common fraction, but the instructions tell me to do this as a mixed number, so I divide the 30 into 253. And by now, this should be becoming a very boring procedure. But that's exactly what I want it to become. I want you to see it as a systematic way of translating from the problems of mixed numbers into the problems of common fractions, solving the problem as a common fraction, and translating back into a mixed number problem. So 30 goes into 253 8 times. 8 times 30 is 240. We subtract, we get 13. 13 what? 13 thirtieths. So the answer is 8 and 13 thirtieths. Okay? Now let's go ahead and look at problem number 4. It's the same kind of a problem as problem number 3, only it's a division problem. Since division was done in Module 5, the only difference between this problem and the last problem is going to be that once we translate into the language of fractions, we're going to be using the material of Module 5 rather than the material of Module 4. You see, we're going to compare 10 and 1/3 divided by 3 1/2, after which we divide by 1 3/5, with 10 and 1/3 divided by the quotient of 3 1/2 and 1 3/5. And by the way, don't be afraid to make estimates over here. This is roughly 10. This is exactly 3 1/2. So this is going to be 3 and a fraction. This is about 2. 3 divided by 2 is about 1 1/2. So we're going to expect an answer for part A to be somewhere between 1 and 2, maybe a little bit bigger than 1 1/2. So at least we know what ballpark we're looking for. And let's go ahead and see how this thing works. All we do is translate back into the language of fractions. And as soon as I've done this, don't you see an exact problem that we did in Module 5? Exactly like this. Remember, we do the division inside first, so we leave the 31 thirds alone, change the division to a times, invert the 7 halves to get 2 sevenths. So that's what it looks like inside the parentheses. Now what we're going to do next is to divide by 8/5. We multiply by 5/8. Now basically all we do is what? Multiply the numerators. 31, 2 times 5 is 10. 31 times 10 is 310. The denominators of 3 times 7 is 21. 21 times 8 is 168. So we divide 168 into 310. We get 1 with a remainder of 142. By the way, notice that this will reduce. And one of the reasons that this will reduce is, even though I haven't done it, notice that what I could have done was come back here and canceled a 2 from both the 2 and the 8 over here. But at any rate, I'm not worried about reducing these things offhand. I have 1 and 142 1/68. I notice that both of these are divisible by 2, so it's 1 and 71 84ths. 71 is a prime number, so the final answer is 1 and 71 84ths. That's all there is to that problem. For part B, it's exactly the same thing, except I have to obey the grouping symbols. Since I'm working inside the parentheses, I first work with 7 halves divided by 8/5. So that's 7 halves times 5/8. That's 35 16ths. So in the language of common fractions, the problem has become 31 thirds divided by 35 16ths. To divide by 35 16ths, you multiply by 16 over 35. You see how the same statements come up over and over and over again? At any rate, 31 times 16 is 496. 3 times 35 is 105. So as a fraction, the answer is 496 over 105. The final step is what? I divide the 105 into the 496. I get 4. 4 times 105 is 420. I subtract, the remainder is 76. So the answer is 4 and 76 1/105ths. 76 is 4 times 19, essentially. 105 is 5 times 21. Working this out, you can see that 76 and 105 have no prime factors in common. This is already in lowest terms. And that takes care of the first 4 problems. And hopefully, at the end of these 4 problems, you will have experienced the difference between difficult and cumbersome. I hope you found nothing hard about this, but you did find that there was a lot of small detail that had to be attended to. Let's now start to apply some other types of applications to the operations that we're doing. Problem number 5 asks us to find 52% of 8 3/4. And again, before you start these problems, estimate the answer. 52% is slightly more than half, right? 50% is half. 8 3/4 is a little bit less than 9. So rounded off, this is about a half, this is about 9, half of 9 is 4.5, so we're going to expect an answer of around 4.5. And that should help us guard against, as I keep saying, gross mistakes. Let's do the problem exactly now. 52%, percent means divided by 100. Divided by 100 means over 100. So we have what? See, 52%, 52 hundredths. 52 hundredths looks like this as a common fraction. Of means times. Now the 8 3/4 we simply rewrite as a common fraction because we know how to handle common fractions. See, 4 times 8 is 32, plus 3 is 35, 35 over 4. Now what can we do over here? We could multiply this whole thing out, but here's a case where I think it's clearly easier to reduce first. You see, 4 goes into 52 13 times, 5 goes into 35 7 times, and into 100 20 times. 13 times 7 is 91, 20 times 1 is 20. So the answer as a common fraction is 91 over 20. And now to get the answer as a mixed number, we simply divide what? 20 into 91. 20 goes into 91 4 times. 4 times 20 is 80. 80 from 91 is 11. The remainder is 11. The answer is 4 and 11 twentieths. And what was our guess? 4.5. And 10 twentieths would have been a half. So we're off by 1 20th. Pretty reasonable expectation on this. Same thing, type of thing now on problem number 6. You see, we want to take 5/6 of 1% of 1,700. And by the way, let me just show you something very quickly here. 5/6 of a percent is less than 1%. 1% is 1 part per 100. Since this is 1,700, 1% would have been 1 for each 100. That would be 17. In other words, if this problem had been what is 1% of 17, the answer would be 17. Since we're taking 5/6 of 1%, we expect the answer to be a little bit less than 17. See, get a feeling for the answer before you even buckle down to the technical details. Now, how do we convert this percent sign to a common fraction? 5/6% means 5/6 per 100. Per 100 means divided by 100. To divide by 100, see, 100 is 100 over 1. We multiply by 1 over 100. 5/6 times 1 over 100 is what? 5 over 600. Which, by the way, we could have gotten much easier by saying, look, when you divide a common fraction by 100, you just annex 2 zeros into the denominator. You see, either way, don't ignore the percent sign. 5/6% is 5 over 600. Of is times what? 1,700. The 2 zeros here cancel with the 2 zeros here. We wind up with 5 times 17, which is 85, over 6. 6 goes into 85 how many times? 6 goes into 8 once with a remainder of 2. 6 goes into 25 4 times with a remainder of 1. The answer is 14 1/6, which certainly is compatible with our guess that the correct answer had to be somewhat less than 17. Okay? Now, that completes the technical end of this. Now what I want you to do is to learn how to read what looks like long word problems to pick out where you're going to use this material. If you can't use the material that you've learned, it's almost as bad as not knowing the material. Arithmetic without application is like having tools without knowing what to do with them. So you can't do anything with tools unless you know when to use them, where to use them, and how to use them. So let's start in with some word problems here. And don't be bothered by how complicated they sound. In fact, in certain senses, the more complicated they sound, the more amazing the simple solution is going to be. Here's one that ties in with the now and the ERA type of situation. An organization requires that at least 45% of its members be women. That's a bylaw. At least 45% of our members have to be women. What does that mean? Out of every 100, 45 have to be women. Well, that's easy enough if you only allowed 100, 200, 300 members, but you're not going to have exactly 100 members. In fact, in this club, there are 65 members. And the question says that if at least 45% have to be women, what's the least number of women that can belong to this club? Well, when you say that 65% of the members have to be women, if the number of members is 65, you're talking about what? 45 hundredths of 65. And by the way, again, you could multiply this whole thing out. You could also say what? 5 goes into 45 9 times, 5 goes into 100 20 times, 5 goes into 20 4 times, 5 goes into 16 13 times, 13 times 9 is 117, 4 times 1 is 4. So as a common fraction, the number of women has to be at least 117 over 4. 4 goes into 117, 29 and 1/4 times. So there has to be at least 29 and 1/4 women. Now that causes a big argument. Which fourth are you going to let in? And since we don't want to brutalize anything, basically the way the problem is solved, and here's what I mean by common sense. If I told you to round off 29 and 1/4, 1/4 is less than half, the answer would be 29, wouldn't it? But the problem says at least 45 have to be women. See, the problem said to solve this problem, 29 and 1/4 have to be women. If you only had 29 women in this club, isn't 29 less than 29 and 1/4? Sure. So the least number you can have, since 29 would be too few, is it must be what? 30 women. See, don't write down 29 and 1/4 women have to belong. 30 women is the least that can belong. Could 50 women belong? Yes, that's the meaning of at least. See, at 50 is covered by at least 30. If it said exactly 45% of the membership has to be women, then this would be kind of an embarrassing problem. But let it go at that. The next application is a financial one. You agree to become a sponsor for a business, and you say to the people, I'll tell you what, for every $7,500 you guys need, I'll agree to supply $6,000. And the question now comes up is, okay, what are you really giving? What percent is that? In other words, if you're supplying $6,000 out of every $7,500 that's needed, what percent are you supplying? Well, forget the percent part so far. Percent simply means parts per 100. What you do know is you're giving what? 6,000 for every 7,500 that's needed. As a fraction, that's what? 6,000 divided by 7,500, which is 6,000 over 7,500. We can start to reduce this to lowest terms. That becomes 60 over 75. 60 is 4 times 15. 75 is 5 times 15. So this becomes 4/5, which, by the way, is an interesting answer in its own right. You see, it sounds complicated to say, I'll give you 6,000 for every 7,500 you need. In much simpler terms, all we're saying is what? For every $5 you need, I'll give you 4. But we want that as a percent. See, at a rate of 4 out of 5, how many are you taking out of 100? Because 100% is the whole thing. See, we're paying what? 4/5 of the 100%. 4/5 of the 100% is 80%. You see, which is the right answer? Are you paying 80% or are you paying 4/5? They're both right answers, but since this problem says write the answer as a percent, 4/5 is wrong, 80% is correct. Once we know you're paying 80%, that becomes like the unit amount. See, now that we know that we're paying 80%, no matter what amount the organization needs, we're going to pay 80% of that. And see, Part B says, if the business requires $40,000, how much must you supply? Well, you have to supply 80% of whatever they need. In this particular case, they need $40,000. So you have to supply 80%, which is 80 over 100, 80% of 40,000. You can either cross off the 2 zeros here with the 2 zeros here and multiply 400 by 80 to get 32,000, or you can rewrite the 80 over 100 as 4/5. Now you're going to take what? 4/5 of 4,000. 4,000 divided by 5 is 8,000. And you see the fast way of doing this again? Don't think of the thousands. Think of 40 as modifying thousands. 40 divided by 5 is 8. So 40,000 divided by 5 is 8,000. 4 times 8 is 32. So 4 times 8,000 is 32,000. So you have to come up with 32,000 of the 40,000. Otherwise, you're not living up to your 80% deal. Okay? Now, let's get into a double discount type of problem. See, a fractional part of a fractional part. Only this time we're going to use the language of percent. And basically, I'm going to make the problem easier than the way that it's usually given. Let me just read this long problem to you also. It says you buy a radio for 75% of the regular price. Later, you sell it to a friend for 60% of the price you paid. And the regular price was $140. And part A says, how much did you pay? Again, if you don't have a number sense, and if you allow yourself to let the language fake you out, this is going to seem like a hard problem. It's a double percent problem, 75%, 60%. But remember, whether it's percents or common fractions, these are adjectives modifying nouns. What this tells me is that whatever the regular price is, I'm paying 75% of that. So when the problem says, how much did I pay? Since I'm paying 75% of the regular price, and the regular price was $140, I'm paying 75% of the $140. 75% is 75 over 100. Reduced to lowest terms, dividing numerator and denominator by 25, that comes out to be 3/4. In other words, 75 out of 100 is the same rate as 3 out of 4. So in other words, I'm only going to pay for 3/4 of the $140. Do you see what that says? See, 75% basically says for every $4, you save 1 and pay 3. At any rate, 4 goes into 140, okay? What happens? If 4 goes into 4, 35 times 3 is 105. So if the regular price of the radio was $140, because you're only paying 75% of that, that's costing you $105. Now we come to part B. Part B asks us, okay, how much did your friend have to pay? Here's reading comprehension again. Your friend pays 60%, but that's the adjective. What's the noun? It's 60% of the price you paid, not 60% of the regular price. So in part B, you don't take 60% of the 140. Your friend is paying 60% of the price that you paid. You paid $105. He's paying 60% of the $105. 60% is 60 over 100. We can cross out the zeros here. 6 and 10 are both divisible by 2. 6/10 is the same as 3/5. So 60% means he's paying 3 out of every 5. 3/5 of $105. 105 divided by 5 is 21. 21 times 3 is 63. In other words, at a rate of $3 out of every 5, he's paying 63 out of the 105. So your friend has to pay you $63. Is that so hard? It's a language thing. You see, it's simple. They're all the same way after you understand how to read these things. Part C says, what percent of the regular price did your friend pay for the radio? Here again is the reading comprehension. How much did your friend pay for the radio? We just found out that was $63. What percent are we looking for? Not the percent of the price that you paid, but the regular price. What was the regular price? Not $105, that was the price you paid. The regular price was $140. So your friend is paying what? $63 out of the 140. So as a fraction, he's paying 63 140ths. Now, what does that reduce to? Let's see if we can handle this. You don't have to reduce this, but I think it's easier. See, 63 is 9 times 7. 9 breaks down into 3 times 3. 140 is, what, 2 times 70. 70 is 2 times 35, and 35 is 5 times 7. So if I break this down into prime factors, I notice that the 7's cancel. My numerator is 3 times 3, which is 9. My denominator is 2 times 2, which is 4, times 5 is 20. So the fractional part that he pays is 9/20ths. But I want the answer as a percent. The answer is a percent. The whole thing would be 100%, so he's paying 9/20ths of 100%. At a rate of 9 out of 20, how much are you paying out of every 100? 20 goes into 100 5 times. 5 times 9 is 45. So even though the price was only 60% of what you paid, because you already got it as a discount, your friend is only paying 45% of the regular price, less than half. And by the way, I said I'd made this problem easier. You can do this problem. You can do part C without even knowing the price of the radio, believe it or not. Look, whatever the price was, isn't your friend paying 60% of 75%? No matter what the price was, you're paying 75%. He's paying 60%, so he's paying what? 60% of the 75%. 60%, as we saw before, reduces to 3/5. 75% reduces to 3/4. Of means times. 60% of 75% is therefore 3/5 times 3/4. That's 9/20. And 9/20, as we just saw, is 45%. In fact, did you notice that the 9/20 here is exactly the same 9/20 that we found doing the problem based on the price being $140? You see, basically what this problem says is we don't have to know what the regular price is, but based on the discounts, for every $140 that the radio costs, your friend is going to pay $63. See, if the radio had been $280, your friend would have paid $126, etc. And now let's come to the last problem for today's assignment, another mixed number problem. Don't you start to feel good when it gets close to the end? Almost worth putting up with me. But I hope that you're starting to see a certain light at the end of the tunnel here. That even if this is hard for you, that you're seeing the same hard problems in a different language coming up over and over and over again. And if you just stay patient, you will learn how to do these problems. You may wonder, how do you learn to do original problems? Again, you learn to walk before you learn to run. You learn to babble before you learn to say coherent sentences, and you learn coherent sentences before you become a creative writer. Well, at least up until the last couple of generations. We won't get into some of that either. But basically, let's go through one more word problem, and let me show you that even though the type of adjectives we're using have changed, the concept stays the same. Problem number 10 says 4 3/4 pounds of apples cost $3.61. And we're asked two parts of this problem. It says, at this rate, part A says, what is the cost per pound? Why do I say at this rate? Isn't it possible that the fellow gave you a better deal for buying 4 3/4 pounds than if you had bought only 1 pound? Isn't it also possible that you're paying by the piece rather than by the pound? See, a whole bunch of assumptions are being made here. So to make the answer meaningful, we don't worry about whether there's a discount or not. We don't worry if some of the apples are big and some are small. All we say is at this rate. In other words, if this is the rate that prevails, what is the cost per pound? Look, nothing has changed since the end of our lecture on Module 3. Per between two nouns is still a rate, and it still means divided by. So let's do this in cents. See, cost per pound means cents per pound. Per means divided by. How many cents are we paying? $3.61. Every dollar is 300 cents, so we're paying 361 cents. How many pounds are we getting? 4 3/4. So cents per pound is going to be what? 361 divided by 4 3/4. What's the only new thing that's happened here that didn't happen until this module? We're seeing numbers like 4 3/4. That's the only difference. Everything else is the same. And by the way, again, if this bothers you, don't be afraid to round off. 361 is around $3.50. 4 3/4 is around 5 pounds. If you can get 5 pounds for $3.50, that's roughly what? 70 cents a pound? 5 goes into 350 70 times. So you're looking at an answer somewhere in the ballpark of 70 cents a pound. It may be a big ballpark, so you may be off by a little bit. But you get the order of magnitude. It's around 70 cents a pound before you even start this problem. Now how do we get the answer exactly? It's a pure drill problem. You see, the word problem is over once you get down to here. If you can't get from here to here, okay, you can't even begin this problem. So the word problem only allows you to go from here to here. Once you're down to here, the hardest part of the problem is over from a creative or innovative point of view. Because now all you have to do is this division problem. Well, how do we divide? We know how to divide when we're dealing with common fractions. So we take the 4 3/4 and write it as a common fraction. 4 times 4 is 16, plus 3 is 19, over 4. And how do you divide by 19/4? Module 5. You multiply by 4/19. So we have 361, which I write over 1 just to make it easier, times 4/19. If you happen to be astute, you'll notice that 19 goes into 361 19 times, and that 19 times 4 is 76 cents per pound. well, 19 times 4 is 76, but the label is cents per pound. If you're not so astute, what's the terrible crime? What's the big deal? You will simply multiply 461 times 4 to get 1444. Then that will be over 19. Then you'll divide 19 into 1,444, and eventually you get what? The same 76 for an answer. This may look longer than this, but if you don't know this, you can stare at this for a long time. In fact, for as long a time as it would take you to do 10 of these problems. Don't look for the short way. Look for a right way. Look for a comfortable way. The short ways will take care of themselves later. Now, part B is actually the kind of question that people sometimes ask without first doing part A. You see, I've made this into a unit pricing problem. But notice that the problem could have said, look, if I pay $3.61 for 4 3/4 pounds, how much will 14 1/4 pounds cost me? You understand that question? I'm going to do the problem an easier way. I'm going to find out how much 1 pound will cost, then 14 1/4 pounds will just cost 14 1/4 times as much. And then I'll close by showing you yet another way of doing that problem. See, to find the price of 14 1/4 pounds, I take, what, the 76 cents a pound, and multiply that by the 14 1/4. And by the way, if I want to do this as a bilingual, the 76 multiplies the 14, and the 76 also multiplies the 1/4. In other words, it becomes a distributive property problem. 76 times 14 comes out to be 1064. 1/4 times 76 means 76 divided by 4. 4 goes into 76. Let's see. 4 into 7 once with the remainder of 3. 4 into 36, 9. So that's 19. So the 14 pounds cost you 1,064 cents. The 1/4 pound cost you 19 cents. Altogether, it cost you 1,083 cents, which we often write as what? $10.83. And if you didn't want to do this using the language of mixed numbers, you could have said what? 14 1/4 is the same as what? 4 times 14 is 56, plus 1 is 57. That's 57/4 times 76. 4 goes into 76 19 times, so the answer is going to be 57 times 19. And I leave it to you to sustain the suspense and see that it also comes out to be $10.83. But I would like, in closing, to show you how, if you have a number sense, you can sometimes shorten problems, but that you don't have to. You see, the real question is, since the given information is based on 4 3/4 pounds, what we would like to know is how many 4 3/4 are there in 14 1/4. In other words, how many times does 4 3/4 go into 14 1/4? Can you almost guess it's going to be around 3? Because this is around 15, give or take a little bit. This is around 5, and 15 divided by 5 would be 3. In other words, you can expect to spend 361 around 3 times. But let's get the exact answer. How many times does 4 3/4 go into 14 1/4? Let's do the problem as we did in problem number 4. Let's convert this to common fractions. 4 times 14 is 56, plus 1 is 57. So this number becomes 57/4. This number becomes 4 times 4 is 16, plus 3 is 19. That becomes 19/4. How do you divide? You leave the first number alone, change the division to a times, invert the second number. 4 goes into 4 once. 19 goes into 57 3 times. 3 times 1 is 3. 1 times 1 is 1. The answer is 3. And that says what? There are 3 bundles of 3 3/4 pounds in 14 1/4 pound. And we're going to check that in a second. I think we have time to check that. Let's actually take 4 3/4 3 times and see what happens. 4 plus 4 plus 4, that's 12, isn't it? 3/4 and 3/4 and 3/4 is 9/4. 9/4 is 2 1/4. So how much do you have altogether? 12 pounds and 2 pounds is 14 pounds, 14 1/4 pounds. Now, if you understand that, you can say, oh, I'm going to pay $3.61 3 times, and if I do that, the answer is what? The same, $10.83. Again, which is the right way to do this? Whichever way you're comfortable with. What would I like you to do? What I'd like you to do is to find one way that makes you comfortable. But don't stop there. Once you find one way to become comfortable, that should give you the confidence to try other ways. Human nature is such that if no way makes you comfortable, you shy away from it. If you know at least one way to bail out of any jam, if you know you have a safety device that will keep you from getting in trouble, that allows you to experiment without any great risk. So the trick will be what? Of all the ways that I show you, of all the ways that are in the text, of all the ways that anybody else shows you, of all the ways you discover for yourself, find the one that makes you the most comfortable. And once you are comfortable, then experiment with all the other ways, because in a given problem, a method that was best for one problem may not be best for another. Basically, there's no such thing as knowing too much. It is better to have something that you don't need than not to have something that you do need. Wow, that was quite profound. I like to give these lectures because every so often I say something I've never heard before. At any rate, this wraps up this exercise set. We're going to start a topic called decimal fractions next time. So until that time, keep studying hard. And let me just interject again. Notice how much of this lesson is a throwback to the previous lessons. And the same thing is going to happen when we come to decimals. So study hard, stay young, have fun. I look forward to seeing you again as soon as possible.